stage 2. Roll back. Okay. The opponent should be your problem for the report.
We would like to challenge problem number 2 here, myself.
Problem number 2.
when a load is pulling on the muscle, and we will stand and it's going to stand and it will make a force. And if we compare to air muscle, if the air pressure inside bigger than the atmospheric pressure, the air muscle will be a contract state and it will cause a force, and it's just like human muscle. And when in relaxed state, the pressure inside equals to the surrounding atmospheric pressure.
So you use your hand to control the pump?
Yes.
Okay. And do you measure the temperature and the pressure inside the balloon?
No, I didn't measure it
Okay.
because I just talk about the ambient pressure, ambient temperature in surrounding.
Okay. Do you think the temperature and pressure inside the balloon will change during the inflation?
I think yes.
Yes. Okay. Do you measure the change of the length and the width?
Can you say?
Do you measure the length and the width of the balloon when you inflate it?
I didn't measure it.
Okay. Do you think that the change in the length and the width will be the same throughout the whole inflation? Like when you inflate the balloon, do you think the change in the length and the width will be the same? The changing rates will be the same?
I think it will a little affect the.
Do you think
It won't be the same at all the time.
it will be the same? Okay. Do you think that? Okay. I would like to ask. In your setup, your spring is held like tilt. So like when you measure the force, it is not accurate. Do you agree? You agree? Okay. Thank you. That's all my question. Contraction and first law of thermodynamics. And her process, she has indicated that equation doesn't fit this condition, and she has also compared air muscle to real muscle. However, she lacked of explanation of the symbol of the formula, and she didn't mention the relationship between elasticity and temperature because she has changed temperature outside the phenomenon. Okay, and the next is about experiment and setup. She changed temperature and times of inflection. A process to change the inflection velocity depends on the outdoor temperature. However, her setup is not accurate enough. For example, the spring that she used to measure the force, she put it tiltly, so I don't think you can get the exact force that the air muscle is stretching it. And the next part, for data analysis, she put the pressure inside and outside the balloon. And her process, she has error analysis, but however, she lack of the title of the axis in some graphs, so it's really hard to understand what she's talking about. And also, she lack of error bar, and she didn't connect with the theory. And some of her graph is fluctuating, but she didn't really explain why. She just said it's just a phenomenon. And next, for discussing point, for theoretical model part, I will talk about what is the properties of air muscle and the similarity between real muscle and air muscle, and also how to define lift height. Because as I just said, her setup is not really accurate. And also, I would like to talk about energy loss and the elastic potential energy and the tension change when the balloon is inflated, and also the temperature and the pressure change inside the balloon. Because the reporter said that she thinks the temperature and the pressure inside the balloon will change as she inflates it. And then at the experiment setup part, I will ask about will the gas leak? Because normally when you pull the gas out into when you push it out and go to pump in again, it will cause some gas leak. So you should have any way to control this problem. And the next one is the role of the net, because in the problem statement it says that we have to use a symmetrical net to put around the balloon. And I would like to know that what is the role of the net in this phenomenon, and why is the net so important? And then I'm going to ask about elasticity. And then for data analysis, I'm going to talk about the error analysis, and also I would like to talk about why will her data trend be like this. And now I would like to invite the reporter to come discuss with me. Okay, and so in my further discussion, I will start from the top of her report, and I will clarify every single report in order to make it run, and I want to build. force that is showing here. Okay. So I think that maybe maybe in the future, you can try different methods of pulling. Maybe you can put everything like in the vertical direction, so you don't have that problem, and then the spring will
I think I can put them on the same level height and maybe this can for the
maybe that will help. Yes, yeah, that will help later. And then so the page 5. So what does it mean when you say that when the balloon expands, it will pull the force?
because the balloon is meant and it will make the force and the pull the spring balance. And this is what we observe.
So you think the force that is pulling is
It's because
the
the
spring?
no, it's because the
So the pulse of force here means the force that will give the spring and the stretch. So okay. And now I understand this one. Thank you. And then I would like to look at page 6. In this part is the observation part, and you say you check you put 1 and 25 degree above 25 degrees and what is under. And can you tell me the exact temperature? Because above 25.
I didn't measure it because I just make the 25 is the
Okay, so you didn't really mention the exact.
yes, I didn't mention.
Okay, but okay, after doing the experiment, can you tell me like what is the difference between above 25 degree and under 25 degree? Okay.
Like I just say the temperature is it's just too small to measure.
So you see that there is still further pulling it, but it's just not big enough so you cannot see it.
Yes.
Is that what you're trying to say? Okay, I think that in paragraph, even though she says that maybe it's the really minor change in the force, however, I think there might be some other factor behind that equation that connected with her theory, and everything to explain why will it be zero, because actually it looks kind of weird because when it is smaller than 25 degrees, you can see a difference between pumpkin times and pumpkin times. Okay, and I would like to talk about page 15. Okay, so my last question will be like, the product statement say we have to investigate the properties of the muscle.
Yes.
Okay, so what do you think is the properties of air muscle?
You say in this page or
No, just for the whole experiment, what do you think is the properties of the air muscle?
I think the air muscle will maybe increase and a high level, and the force will be decreased because the air outside
Is increase and decrease.
yes, and it's just like air muscle is similar like air muscle like cooler muscle.
I think that the properties of the air muscle is that even though you expect one thing inside of the net, but what you will do is not just expect inside.
Okay, your opponent should summarize this.
So from a further discussion time, first I clarified a lot of things in her report and about how she measured the force, and I think that is not really accurate. And she also agreed with me that maybe she can put it in the platform or vertically to get a more accurate force. And then also we also talked about why temperature will change, and she didn't really answer my question that why when the temperature is higher, the force will increase or decrease. However, I think that maybe she should find a theory to connect with her phenomenon. I think it's really important. She cannot just mention the observation. And also, and then we talk about what is the properties of the muscle, as what the current statement is asking us. And she says that it's the pulling of the force. However, I think that the property of the muscle is because what it expand is not in the balloon, but what it can happen is that the length of the net will be shorter. So that's all for my summary. Thank you.
Okay.
Okay, thanks for the reporting opponent discussion. So, and according to this reported setup, so did you change the net and because you have spring in your experience every time?
I change the net every time.
Okay, thank you. And about the balloon, we are talking about the procedure of the balloon. And so, do you have control the balloon position in your net every time? Is that the same or not? Is it the same or you didn't do it?
I didn't change.
So, do you think that decision will affect the procedure?
I think yes.
How about opponent's opinion?
Yeah, I think that's that.
Okay, so the next question is about the balloon and the net. So the balloon and the net in your experiment, pay attention to the state of it. It's not seems like about your contact area, or that's about your contact area between the balloon and the net. So when you cross to the maximum, and do you think that the contact area will be always like we all the balloon will the area will always contact the whole net or did you measure it?
I think yes.
Okay, so you think yes. Okay, how about opponent's?
I don't really think so. Even like in the front and bottom of the net, it will be connected.
So if it's not because you think that, do you think that will have any effects on it? Have any effects about the result?
No, I don't really think so.
Okay, the result. And about the next question is because you talk about the length, because the report is focused on length. But I want to ask you, did you recover the width or your muscular?
Can you say again?
The width. So it's length and your width. So do you record it?
No, I didn't.
Okay, so you did, and do you think that it will have a significant effect on your experiment?
I think it's just a little effect on my experiment.
Okay, so and attention to the page 8 about your temperature. And also I want to ask the opponent, because you talked about the temperature and the pressure inside the balloon, but you didn't ask for the reporter in this discussion. So can you explain that if there is a different temperature or pressure inside the balloon, we'll have a different energy loss? So do you have any opinion about it?
Yeah, I think the pressure inside will decrease and increase, and then the temperature will increase by one.
Also about the temperature and the pressure. So which one do you think is more significant effects on the result?
I think both is really significant.
Both?
Yes.
Okay, you stick both. So how about a reporter's opinion? The pressure or the temperature is more important besides the balloon?
I think the gas surrounding the airport is also different.
Also, the next question for the both reporter and opponent. Do you think that when we keep the pressure inside the balloon, the volume of the balloon will keep increasing or not?
Yes, I guess.
So we keep pumping air into the balloon, the volume of the balloon will keep increasing or not?
So there is something of the limit.
How about the reporter?
The radio will become bigger, and next one the gas is expanding.
Okay, so hello everyone, I'm the reviewer from the Team Maxwell, and today I'm going to review the proper number 2, air muscle. So this is the proper statement, so we have to place a balloon inside the cylindrical neck, and we have to inflate the pressure in it, and the neck will expand and be shortened. So we have to investigate the property of such a muscle. So this is a summary of the report. So about the theory explanation, the balloon expands and the neck will constrict the balloon, and use the ideal gap law. And about the first generation, considering the pressure and the area, about the effects of temperature and the length, environmental temperature, and about experiment, the neck constricting exerts force, and the higher temperature will increase the force exerted by the muscle. And for the force increase shows that when the balloon is locked, and compare the change in length for different situations connected to the muscle. And about the strength, we see that there's a very many parameters and complete observation about it, and compare it with the real muscle, and provided some equation for us to calculate the force and effect on pressure inside the balloon. But the suggestion I give the report will be like the setup may be that accurate and controllable, and about lack of the quantitative explanation and lack of the comparison between the theory and experiments. And he provided data for force exerted and pressure inside the balloon, but he did have a very clearly explanation and could do more parameters and experiments to show the trends. So next key. And then about the summary of the opponent. They talk about the theory explanation about the change in the temperature during the inflation of the balloon inside the balloon, and the change in length and weight and the rate of change. And the experiment they talk about is changing the balloon, and because they didn't connect the balloon and the spring vertically. And the next one is pointing out the errors in the setup and energy conversion efficiency, and the role of the neck, because according to the proper statement, we have to know what the neck working in this experiment, and the property of the air muscle, what kind of property we're going to find out. And about the strength component, we clarify the experimental procedure and discuss the role of net. The suggestions didn't consider other property and can talk more about the theory. It didn't discuss the energy loss. He asked for the reporter. And about theory, the opponent asked the change in temperature will balloon is inflated, and the reporter said yes. And the role of the net, the reporter said the control of the balloon. So in my opinion, I agree. And next page. And about experiment, the opponent assessed the spread out the line with the muscle. Now, the reporter said will have effect. And about the word first from, the reporter from the net pulling on the spring. So the first question I agree with the opponent, and second I agree with the reporter. So the first from the net pulling on the spring. So next one. And this is when does the change slow down? And the reporter said the balloon fill net. And I agree with the reporter. And about my own question for the reporter is will position of the balloon affect? Alright, will volume of the balloon keep increasing when we pump the air inside the balloon? And the reporter, both answers yes. And I agree we should consider. And about my problem for opponent, will the position of the balloon affect? They also answer yes. And the different temperature and pressure inside or environment will have a different result. And pressure will decrease and increase. And about energy conservation will be limited. So I agree with the opponent. So this page is show that the mispoint in their discussion. So the first one is why muscle contracts. And the second one is wear and tear of the net. So the net role, he didn't very discuss this clearly in their discussion. And other property of the muscle like width, length, ratio, or volume. And because we are going to compare the air muscle and the real muscle, we need to compare the width and the length. And about it, didn't discuss why force decreases. Because the temperature, environmental temperature effects. And the position of the balloon and the contact area of the balloon and the net. And energy loss, because the opponent asked the energy loss, but she didn't have a discuss with the report. So this might be my review. Thanks.
Now, the question from the Well, I don't have a good question. If you change the structure of the net, or the total
I
length
think yes, I will do it this time, and I will do more. I will do very less outside of it and in the future.
Well, this is a physical question. If you change the structure of the net, but the total length cover the balloon remains the same, how do you affect the result? Just quick explanation. Okay, no comment?
I think that if you change the structure of the net and you say that the contact area with the balloon is still the same,
Yeah, the
and
total
I think
length.
that maybe the force that it will it will make it shorter, will be different because of the different structure of the net.
Because I think we will change the material of the net, so the constrict force from the net will be different. And maybe the contact error will be different when we pump the air into the balloon and about the, and so that's my answer.
I think if we bump into the airline and the resonance and because the force becomes more significant, then we put no resonance net on the balloon.
So it's the air muscle, right? So it's used to mimic the real muscle, but it is not perfect. So what will be the major difference? Real experimental or theoretical farming?
I think we also have many muscles in the same traits and detail of it. But this one is just one muscle. So if we want to make the air muscle become more like real muscle, we can put many air muscles in the same way to make sure it is more similar with the real muscle. Just like it has many muscle in the same hand, and we can put many air muscle in one place.
Okay, but my answer is that I think that the major difference is that in real muscle we have two parts. There's upper part and there's lower part. So when the upper part muscle it gets bigger, the lower part will get smaller, it will get thinner. So that's why it will have the phenomenon to happen. However, in air muscle we only need one balloon, which if we refer to the human body, it's like one part of the muscle to make the phenomenon happen. I think that is the major difference.
So I agree with the point, and I think there's another question is about flexible. As you can see, the air muscle is not flexible as the real muscle, and the direction change is not as our real muscle, and the next is about energy transfer, and the efficiency of the energy transfer to the different parts in our body and our air muscle.
One more question. I think all of you already agree that once the air muscle goes through the intense cycle, then the plastic deformation occurs. So do you have any idea about the generic behavior of the plastic deformations around the system? Any ideas? And how to quantify plastic deformation?
To answer first, I think that first the tension will increase in a really short second is because that the air has to break through the limits of the balloon, so it gets bigger and bigger. So once it goes through the limit, then the tension will decrease. It's because the wall of the balloon will get thinner and thinner, so the tension will decrease. However, when it gets really big and it gets almost the limit of the balloon, the second part is the tension will decrease because it gets thinner and thinner. And then at the third part, the tension will increase. It's because that there's no more space for the balloon to expand. It has already got the limit of it. So the balloon will get harder. Therefore, the tension will get even higher. I think that is the change.
So first of all, it of course the natural limit of the balloon, and the second one is because when we grow. And it grows to a certain like as big as the balloon, they will have a trend with the balloon to keep to the become longer. They'll have a trend because the net will be a constrict force to the balloon. And about just like in my review I talk about the growth, just like we keep pumping the air, the volume will be always increased or down. Thanks.
Okay, just a quick answer.
I think it will make the network plastic becoming and it will make a real effect. And I think the balloon will become bigger until the net gets it will become because it doesn't have very much of okay.
Okay. Now, Starting for the reviewer. 8, 6, 7, 8, 7. Okay, now let's conclude stage 2.